Rate of change and slope. When you hear rate of change, usually you will be provided with some data, maybe in the form of a table like the one I'm drawing below. And there will be two variables which are generally labeled as x and y. So that's what I'm going to write in the top row, x and y. And then both of these variables will take on different values. So say x takes 4, 5, 6, 7. And let's say the corresponding y values are 1, 3, 5, and 7. And then you will be asked to find the rate of change. Now, the interesting thing to notice here is x is going up by 1 by the same amount, from 4 to 5, 5 to 6, 6 to 7. So each time x is going up by 1 and y is going up by 2. So it goes from 1 to 3, then 3 to 5, 5 to 7. So each time x goes up by 1 and y goes up by 2. So whenever you have information presented like that, then you say that this is linear data. So what is linear data? Whenever x changes by a fixed amount, y changes by the same uh, another fixed amount. So y also changes by the same quantity. Not necessarily by 1, but by some fixed number. And the reason it's called linear data is because if you were to plot all these points, if you take the corresponding pairs of x and y values, so 4, 1, 5, 3, 6, 5, and 7, 7, and plot them in an xy plane, so x and y, if you have a graph paper, and if you were to plot these points, so 4, 1, will be somewhere here maybe. So I'm plotting this point 4, 1, then 5, 3, then 6, 5, and 7, 7. So 4, 1 might be here. So let me write it down 4, 1. 5, 3 might be somewhere here. And 6, 5 might be here. And 7, 7 might be here. So all of these points will fall on a straight line. That's why this is called linear data or linear function. And when the data is linear, then the rate of change is nothing but the slope. Now, I have a video entirely dedicated to slope where I defined it as rise over run. So in other words, we look at the rise, which is how much y is changing by. So if y is going up by 2, then we say that the rise is 2. And whatever x is changing by, so x is going up by 1 here, so that's called the run. So in this case, the slope is going to be 2 over 1, which is equal to 2. So slope is 2, which means the rate of change is also 2. Now let's look at one other example. So this time, what I'm going to do is give you data which goes maybe like this: -2, -1, 0, 1, and 2. And say this is going 5, 8, 11, 14, 17. So again, you might notice that x is going up by 1 from negative 2 to negative 1. So it got a little less negative. And then from negative 1 to 0, that's also an increase. And 0, 1, 2, you can see that all of these x values are going up by 1 and y's are going up by 3. So its immediate rate of change for this function is 3 over 1, or just 3. Now, rate of change is the same as the change in y if x is going up by 1. So it's the same as slope. Now, what happens if let's say xy. Now, maybe I can keep the same x values as in example 2. But now let's say this is, it's starting high, say 20, then going to 16, 12, 8, and 4. So notice, x is still going up by 1, but this time y is going down by 4. So in this case, rate of change is going to be negative. It's no longer positive because y is going down. So rate of change is going to be negative, and it's going down by 4. All right, let's look at one other example. Yeah, let's start numbering our examples. So example 4. So this time I'm going to keep x's going up by 1 again, and let's say we can start at 8, then 9, 10, and 11. And let's say y is negative 5, and it's negative 5. So what would be the rate of change? So notice, x is going up by 1. So I want to know what's happening to y. Y is neither going up nor going down. So it remains same, which means there is no change. So rate of change is actually 0 here. All right, in all these examples, x was going up by 1. So let's look at some other example where x's do not go up by 1. So say x and y. Now let me say I'll start at negative 5, then negative 3, then negative 1, then positive 1, and then 3. And say y started at 9, then let's say the next value is 15, then 21, 27, 33. So notice, x is going up by not 1 this time, but it's going up by 2. From negative 5 to negative 3, that's an increase of 2. And you can notice, negative 3 to negative 1 is an increase of 2. From negative 1 to 1, that's an increase of 2. And from 1 to 3, that's again adding a 2. So x is going up by 2, and what's happening to y? It goes up from 9 to 15, 15 to 21, 21 to 27, 27 to 33. Now these numbers are getting a little bit bigger, but you might have already noticed that y is going up by 6. So what is the rate of change? So this time I can't say that the rate of change is 6, by just looking at how much y is changing by. So y is changing by 6. So that's going to be our rise. But we have to divide by run, which is actually 2 in this example because x is going up by 2. So 6 divided by 2 is the slope or the rate of change. So that's going to be 3. All right. So in all of the previous examples, x was going up by 1. So I could have divided by 1, but dividing by 1 is not going to change the answer. So I can say that the slope is, or the rate of change is the change in y itself. But if it goes up by a different number, then we have to divide by that. Now, what I'm going to do in the next example is I'm going to use maybe, let's number all of these examples. Example 1, example 2, example 3. So say you're not given, let's look at example 2 one more time. So this is the example 2. So sometimes your data is given like in example 2 where x is going up by 1. But sometimes your data will be given a little bit differently. So for example, they may skip some rows here. So let me modify example 2 and remove few of the rows. So let's say you're given the first row, -2, 5, but then you may not be given the next row, -1, 8. You might be given 0, 11. And then you might be given the next one, which is 1, 14. So when you look at this data, when you look at example 6, you might notice what's happening to x. X has first gone up by 2, but then it only went up 1. So how are we going to find the rate of change? Well, in that case, the best thing to do is to simply follow the formula. The rate of change is slope, which is rise over run. So rise over run. And then you want to look at the rise. So you pick any 2 rows of your choice. So if I pick the first row, actually, I'm not going to choose the first row because it has a negative number. But maybe I want to pick row 2 and row 3 and look for the rise. So when I look at these 2 rows, the rise is from 11 to 14. That's a jump of 3 units. So that's the rise, and the run goes from 0 to 1. So that's equal to 1. So 3 over 1 is 3. So you say that the rate of change is 3 by simply looking at the rows and looking at the rise over run. Now, if you have trouble or if the numbers are not nice, you might want a formula. So you recall the formula for slope is y2 minus y1 over x2 minus x1. So you can use that formula and plug those numbers. So your y1 is the first y value, y2 is the second y value, and similarly x1 is the first x value, x2 is the second x value. So when you plug those in, you get the same answer. All right. So that's how you can find the rate of change. So to summarize, if your data is presented nicely, where x goes up by 1, then rate of change is simply whatever y is changing by. So if y is going up by 2, then your rate of change is 2. Oh, we did not write here, but we said it. Rate of change is 2 there. Here, again, x is going up by 1, y is going up by 3. So rate of change is 3. In example 3, we see x goes up by 1 and y goes down by 4, so rate of change is negative 4. And then in example 4, x goes up by 1, but y goes up by 0, or y actually does not go up, so the rate of change is 0. Now, if x goes up by something else, but the same number in each, when you go from one row to the next, and y goes up by the same number, then you take the rise over run. And sometimes the rows are skipped. Like here, x is going up by 2, but so let me look at this example 6. At first, x is going up by 2, and then it only goes up by 1. So you don't want to say that, oh, yeah, you can't tell the rise over run ratio right away. So you got to look at 2 rows and then conclude. Use the slope formula and write it down. Alright, so that's all for the video. Now I'm going to have some practice problems that I have already written, and the answers to these practice problems will be in the video description. So good luck, and I will see you in another video. Thank you.